So, welcome students. Today we'll learn a radioactivity. So, what is the meaning of radioactivity? It is the decay of nucleus or spontaneous disintegration of nucleus. So, a nucleus spontaneously disintegrates by emitting the rays like alpha, beta and gamma. So these rays, alpha, beta and gamma, are called radioactive rays. These rays were discovered by Henry Becquerel. That's why these rays are called Becquerel rays. So, while discovering the rays, when Becquerel applied an electric field, he observed that some rays are deflected towards positive plate, some rays are deflected towards negative plate, and some rays pass without any deviation. So, those rays which are deflected towards positive plate, he named it as beta rays. The rays which are deflected towards negative plate, he named it as alpha rays. And the rays which pass without any deviation, he named it as gamma rays. So, from this experiment, we can have a conclusion that beta rays are negatively charged, alpha rays are positively charged, and gamma rays are neutral. So, next we will understand the properties of alpha, beta, and gamma rays. So, first, nature. Alpha is a material particle. It is a double ionized helium nucleus. So, its symbol is 2He4. Beta, it is also a material particle. It is fast moving electrons, or the electrons originate from nucleus. So, its symbol is -1E0. Gamma ray, this is electromagnetic radiation of short wavelength. So, it is h nu, where nu is the frequency. Now, we'll go for the charge. The charge of alpha is +2e. The charge of beta is -e. And gamma is chargeless. Mass. Mass of alpha is 6.6 into 10 to the power -27 kg. Approximately 4 times of a proton. It has the mass of electron, so it is 9.1 into 10 to the power -31 kg. And gamma is massless. Next one is speed. It is 10 to the power 6 to 10 to the power 7 meter per second. Beta, it can have a speed up to 0.99 times of speed of light. It moves with speed of light. Gamma has the speed of light, that is 3 into 10 to the power 8 meter per second. Next one is effect of electric field. So, as alpha has positive charge, it deviates towards negative plate. Beta, it is negatively charged, so it deviates towards positive plate. and gamma, it is chargeless, so it has no deviation. Next, effect of magnetic field. So, if we apply a magnetic field to a charged particle, it is deflected from its path or deviates from its path. So, alpha and beta are charged particles, so they will deflected in the magnetic field. But gamma is chargeless, so it has no deflection due to magnetic field. So, gamma rays will pass in a straight line if electric or magnetic field is applied. Next, ionization power. The ionization power of alpha is high. Ionization power of beta is medium or moderate. The ionization power of gamma is low. Next, penetration power. The penetration power of alpha is low, beta is medium, and gamma is high. Next, interaction with matter. Interaction with matter of alpha is high, beta is medium, and gamma is low. The last one, decay equation. So, if a nucleus disintegrates by emitting a alpha particle, then its atomic number decreases by 2 units and mass number decreases by 4 units. For beta, if a nucleus disintegrates by emitting a beta particle, then its atomic number increases by 1 unit and mass number is unchanged. If a nucleus disintegrates by emitting a gamma ray photon, then there is no change in its atomic number and its mass number. Just it comes from an excited state to ground state. So its energy state only changes. Next we will go for laws of radioactive decay. So, first law is that radioactive decay or radioactive disintegration, it is a spontaneous process. So, it is unaffected due to external conditions like pressure and temperature. Radioactive disintegration is due to spontaneous disintegration of the nucleus. So, it is unaffected due to external conditions like pressure and temperature. The second law is that in radioactive decay, the number of nucleons and charge is conserved. So, in a radioactive decay process, the number of nucleons and charge is conserved. That means the total number of nucleons before disintegration must be equal to number of nucleons after disintegration. So we can say the mass number A and atomic number Z must be same before decay and after decay. The third law is that a nucleus can emit only one alpha or only one beta at a time. That means a nucleus cannot emit more than one alpha or more than one beta or combination of alpha and beta at a time. But gamma ray can be emitted with alpha or beta decay. Next one. The radioactive decay process is completely probabilistic. We cannot say or predict which nucleus will be disintegrated at what time. A nucleus can be disintegrated at the moment we are looking at it, or it may remain undecayed after million of years. So it is completely probabilistic in nature. Then we go for Soddy-Fazan's group displacement law. So in alpha decay, so what are the group displacement laws? In alpha decay, the atomic number decreases by 2 units and mass number decreases by 4 units. So in periodic table, if this is x, y will be 2 places left to x in periodic table. If we go for beta decay, the atomic number increases by 1 and mass number is unchanged. So in beta decay, y will be 1 place right to x. But in gamma decay, there is no change in atomic number and mass number. So there is no change in place of the nucleus in the periodic table. Then we will go for statistical law of radioactive decay. It says that the rate of disintegration at any instant of a radioactive sample is directly proportional to the number of radioactive nuclei present in the sample at that instant. So the rate of disintegration of a radioactive sample at any instant is directly proportional to the number of radioactive nuclei present in the sample at that instant. So let us consider a radioactive sample. So initially the number of radioactive nuclei is n0. So at time equal to 0, the number of radioactive nuclei is n0. After time t, the number of radioactive nuclei becomes n. Now, in a very small interval at this instant, in a very small interval dt at time t, let dn number of radioactive nuclei are disintegrated. So, number of radioactive nuclei present at time t plus dt will be n minus dn, because at time t the number of radioactive nuclei is n, and in time dt the number of nuclei disintegrated is dn. So, the remaining number is n minus dn. So, the number of radioactive nuclei decreases with time. So, the rate of disintegration is minus dn by dt. So, the rate of disintegration at time t is minus dn by dt. Here, the negative sign suggests that the number of radioactive nuclei decreases with time. So, we can say minus dn by dt, according to this law, minus dn by dt is directly proportional to number of radioactive nuclei present at that instant. So, minus dn by dt is directly proportional to n. This is called statistical law of radioactive decay. So, at time t equal to 0, the number is n0. At time t, the number is n. Now, we can say minus dn by dt directly proportional to n. So, minus dn by dt is equal to a constant into n. This constant lambda, this is the constant of proportionality. This is called decay constant or radioactive disintegration constant. So, we have to solve this differential equation. So, we will apply variable separable method. So, we can write dn by n equal to minus lambda dt. Now, integrating with proper limits, we can write integration of dn by n equal to integration of minus lambda dt. Now, time changes from 0 to t. Now, at time t equal to 0, the number of radioactive nuclei is n0. At time t, the number of radioactive nuclei is n. So, integration of dn by n from n0 to n is equal to integration of minus lambda dt from 0 to t. So, integration of dn by n, it is ln n varying from n0 to n. Minus lambda is a constant, the integration of dt is t. Now, time varies from 0 to t. That implies ln n minus ln n0. It is equal to minus lambda into t minus 0. So, ln a minus ln b, it is equal to ln a by b. So, we can write ln n by n0. It is equal to minus lambda t. Now, taking the base as e, we can write n by n0 equal to e to the power minus lambda t. So, n equal to n0 e to the power minus lambda t. This is the mathematical form of statistical law of radioactive decay. Now, if we draw the graph n versus t, The graph is like this. At time t equal to 0, the number is n0 and the graph decreases exponentially. So, the nature of the graph is exponential decay. N equal to n0 e to the power minus lambda t. So, now we will define decay constant lambda. So, first we have minus dn by dt equal to lambda n. So, lambda equal to mod of dn by dt by n. So, we can define lambda as the ratio of rate of disintegration at any instant to the number of radioactive nuclei present at that instant. So, lambda equal to ratio of rate of disintegration at any instant to the number of radioactive nuclei present in the sample at that instant. Now, we also have the formula n equal to n0 e to the power minus lambda t. When t equal to 1 by lambda, then n equal to n0 e to the power minus lambda into 1 by lambda equal to n0 e to the power minus 1. So, n equal to 1 by e times of n0 or 0.637 times of n0 or 63.7% of n0. So, we can define lambda as the reciprocal of time after which the number of radioactive nuclei becomes 1 by e times of its initial value. Lambda is the reciprocal of time in which the number of radioactive nuclei becomes 1 by e times of its initial value. Now, its SI unit is second inverse, dimension is t to the power minus 1. Practically, we can say it is minute inverse, hour inverse, year inverse or day inverse.